what I'm going to do in this video is attempt to create an implementation of the insertion sort algorithm that we talked about in the last video. And I'll do it as a Python function. So I'll call the Python function insertion sort, and it will take in a list. So list is its parameter in the function definition. Someone would have to pass list as an argument. And what we're going to do is we're going to step through each of the slots in the list. I guess we could call it that way. So let's say for index in and range. We could start at the leftmost slot in the list. So we could just say len just means is short for length. So length of the list. So what this would do, this would start index. So let's say the list has 4 elements in it. Then len list, this right here would be 4, would evaluate to 4. Range of 4 would produce a list that has the elements 0, 1, 2, 3 in it. And so index would be able to step through the different indices for this list right over here. And we could do it that way, but you might remember from the previous video that when you're doing the insertion sort, it doesn't actually make sense to start at the very leftmost element because there's nothing to compare it to the left. So we can actually just start at the second to the leftmost element. And the leftmost element is the 0th item, so we can start at the first item. So now if the list has a length of 4, this right here will produce 1, 2, 3. So 1 would be the second to the leftmost element, 2 would be the next one to the right, 3 would be the last one. Remember, we always start our indices at zeros. The 0th term is the leftmost element in a list. So fine, we can step through that. And well, let's get the value of at that point in time of the element that is at that index. So that way we don't have to keep finding it. Value is equal to list index. And this by no means is going to be the most efficient implementation of even insertion sort. It's just going to be my best try writing it in real time and in a way that hopefully you might be able to understand it. So value is just the item in the list at each of those indexes that we're now going to compare to all of the items to the left of it. And what I want to do is compare value. I want to compare value to each item to the left of it. So let's define a variable I, and let's let this be the index of the things that I want to compare value to. And right from the get-go, I want to compare value to the thing that is left of it. So I should have one lower of an index than index. So index minus 1. So this is the index of the item that is directly left to it. But we're going to keep taking I lower and lower so we can keep comparing value to things further and further to the left. And so what we want to do is we're going to want to keep comparing further and further left until I has gotten all the way to the beginning of the list. And I has gotten all the way to the beginning of the list when it is equal to 0. So what we want to do is we want to perform this while I is greater than or equal to 0. Because if we keep taking I lower and lower and lower, we're going further and further to the left in the list. We don't want to try to perform it when I is, further is a negative number. That'll just start doing crazy things. So while I is greater than or equal to 0, what I'm going to do is I'm going to keep pushing I further and further to the left. So let's try it this way. So the first thing I want to do, we've already pushed it to the left once. So let's compare. So if value is less than the, this thing keeps saying syntax error because it's waiting for me to keep typing. If value is less than the item that is now at index I. So the item at index I, the item at index I is this right here. So if it is less than that, let's shift the item that's over here. Let's shift it 1 to the right. So the right slot is I plus 1. And I can't just say it's index, because remember, I'm going to keep pulling I in lower and lower and lower. So because right now I is index minus 1 in the first pass through this while loop. But I'm going to, as you'll see in a second, I'm going to keep lowering I. So it always won't be 1 left of index. So I'm going to say wherever I is, let's take the spot 1 to the right of I. 1 to the right of that, so that's I plus 1 is its index. And let's replace that with whatever's at list, and whatever's at I, at slot I. So we've essentially taken this thing right over here, whatever number was there, and we are putting it in the slot that is 1 to the right of it. And actually, the way we're setting up that algorithm, whatever's there is actually going to be, well, I won't talk about that. We'll step through it and see how it all plays out. And then we can shift value. We can shift value to the left. So whatever was in this slot right over here will be replaced by value. So list I will equal value. So one way to think about it, let me write a comment here. Shift shift number in slot I to slot I plus 1, or you could say bucket I plus 1, I guess is the one way to think about it. And then you could say shift number right. Let me call it this way. Shift number right in slot. Let me write it this way. Shift number in slot I right to slot I plus 1. And then over here we are shifting. Here we are shifting. Shift value left into slot I. And so if you remember what we did in the last video, this is exactly describing it. We're comparing value to the thing to the left of it. If it's less than it, then whatever number was in that box to the left of it, the slot to the left, shift it to the right, and then shift value to the left. And now compare value to something 1 lower than that. So we want to decrement I. We want to lower I. Decrement is just increment down. So I is equal to I minus 1, and then we'll perform the loop over again. We'll perform the loop over again, and now value will be compared. Now I is 2 to the left of index. Compare it to that. If it is less than it, shift that to the right and shift value again to the left. Now, what if we have the situation where value is not less than the item that you're comparing it to? Well, if it's not less than the item that you're comparing it to, and that means that value is already going to be in the right place, and it also means that you're done, that you don't need to shift value any more to the left, and you don't have to shift any of the stuff to the left any more to the right. So then we are done. And I think this could work, unless I've made some silly mistake. So let's try to see if I can get this, if this actually works as a sorting algorithm. So let me save it. Insertion sort, and let me run it. All right, so I didn't have any, at least, syntax mistakes. Syntax just means the actual, the actual characters I use. I didn't forget to put a colon here or a greater than sign, or I didn't. It was actually able to process this, interpret this right over here. But let's see if it actually works. So let me define a list. Let's say it is 7, 1, 3, 5, 9, 2. 2, and then let me put another 3 in there. So that is A. And then let me see, this is the moment of truth. Insertion sort of A. Let's see what happens. So remember, we're sorting it in place. This function doesn't return anything, but it should take whatever list that was and had changed up all of the elements so that now they are in order. So this is the moment of truth. Let's see what A looks like. There you go. It is sorted. So I don't think I made any major mistake. So there you go. You have insertion, a version of insertion sort.